In this video, we'll see how to solve systems based on word problems, and for organizational purposes, I'll have a chart where we're going to extract the information from the problem and see how to write the system about it. After that, we'll solve it. All the problems will be related to some kind of animals, pets, birds. So as a common name, I called it a pet problems in systems lesson. In first example, we have 25 animals on the farm, and they are either pigs or chickens. So what we know here is that we have 25 animals and they are either pigs or chickens. The sentence doesn't say how many pigs, it doesn't say how many chickens, it's just a combined total of 25. So it could be 10 and 15, it could be 5 and 20, it could be 12 and 13. So any combination of pigs and chicken, that is 25. But it can't be just any number that adds up to 25. The second sentence says that the animals have a combined total of 64 legs. And this is when this information becomes useful, because we can't just have any combination of pigs and chicken that add up to 25. This is important, that combined legs of both add up to 64, and that's the only possible answer that we're going to find out. The question is how many pigs and how many chickens are on the farm. The information about legs is commonly known that every animal has 4 legs. So pigs have 4 legs and birds have 2. So chickens have 2 legs. That's something that doesn't say in the problem, but we just know or use our prior knowledge about animals and how many legs they have, or birds. So in our animal sentence, or in our information about animals that we have in the first sentence, is that we have a number of pigs plus a number of chickens add up to 25. So we have in the problem pigs and chickens that add up to a total of 25. How many of each? We don't know. So we're going to use 2 variables. In the system, we have 2 variables. We can use x and y, but we need to make sure that we remember which is which and label them. Or we can use p and c, because there are 2 different variables and we can use them for a total of 25. Then every pig has 4 legs, so we're going to multiply the number of pigs times 4. That means 4p. Every p multiplied times 4. Every pig has 4 legs. And plus every chicken has 2 legs, so every chicken has 2. That means multiplying the number of chickens times 2, because every chicken has 2 legs. That will be the total of 64 legs in the problem. That is our combined number of legs. In our system, we have 2 equations, and the first equation represents the number of animals. The second equation represents the total of legs and how many legs does the animal have. So every pig times 4 plus every chicken times 2 will add up to 64. That creates a system that can be solved by using elimination. I would multiply the first equation by -2, just because it is a smaller number and it will create an opposite for 2. So creating opposites for the variable of your choice. -2p will be -2c, and it will equal -50. Multiply -2 by all the terms. Second equation will remain the same. 4p plus 2c equals 64, where we'll have our opposites and they will eliminate. -2 plus 2 will be 0, and then combining the equation in the system, 2p will equal 14. Dividing by 2, we'll have p 7. That is the number of pigs. So now we can say that on the farm there are 7 pigs. out of the 25 total, how many chickens would that be? So the pigs and chickens together were 25. Now we know that we have 7 pigs because we can substitute that 7 and then using inverse operation subtract to find the number of chickens, which is 18. So 18 chickens. We have 7 plus 18 equal 25, so that is the number of animals on the farm. But we still need to check in the second equation. So let's say I have now 7 pigs. 7 times 4 equals 28. That's 28 legs total. And then for chicken, we have 18. 18 times 2, that would be 36. 36 legs. If you add the total number of legs, 28 for pigs, and total number of legs, 36 for chickens, 28 plus 36 will be 64 total. And that works. If we found our number of pigs and chickens correctly, then multiplied by their number of legs and added together, it will be our combined total. And that's when you checked your solution to make sure it works. Let's see another equation to see another example to see how to set up equations. The local park has ducks and squirrels. So in the park there are ducks and squirrels. Ducks are birds. Ducks have 2 legs. Squirrels are animals, and they have 4 legs. So every duck multiplied times 2 and every squirrel multiplied times 4, because we have 2 legs for each duck and 4 legs for each squirrel. Then there are 24 animals in the park with a combined total of 82 legs. So we don't know how many ducks, we don't know how many squirrels, but we do know it's a combined total of legs, 82. So first of all, what kind of animals do we have? And the sentence here says that we have ducks and squirrels. How many total? 24. So that is our equation that could be created about the number of animals in the park. So we can use D and S, or we can use again X and Y, as long as you remember which is which, or label them, and the total is 24. Then we have the combined total of legs. So the second sentence will be about legs. And the total is 82. Every duck has 2 legs, so every duck times 2. Every squirrel has 4 legs, so plus, because it's about total, 4 times S. Every squirrel has 4 legs. And that becomes our system, D plus S, ducks plus squirrels, for the total of 24. 2D, every duck times 2 legs, plus 4S, every squirrel times 4, equals 82. And that's when we need to start by creating opposites in order to eliminate. I'll multiply by -2 the first equation to create an opposite for 2. And the second equation remains the same. Then we add 82 minus 48, 34, dividing by 2, 15, 17 squirrels. 17 squirrels will be used to find the number of ducks, because we know that there are 24 ducks and squirrels together, 17 of them being squirrels. We can subtract using inverse operations, and that will give us the number of ducks. When we check, because we know that 7 plus 17 is 24, well, that's something that we used in the first equation. If the solution works in the second equation, then we know it's right. So we know that there are 17 squirrels, so the squirrels is 17. 17 times 4 is 468. 4 times 7, 28, to 68, and then ducks, we have 7. Every ducks times 2 will be 14 legs. And then we add 14 plus 64 to see if the total works, and that would be 2, 7, 8, 82 total. And that is 82 total that we had in the problem, which checks out. For the last problem, I'll let you try, but the only piece of information that I will help you with is setting up the system where we have ants and spiders. So we have 26 insects in the yard, and they are ants and spiders. So we have insects, ants, and spiders. For what total? And ants have 6 legs, spiders have 8. So for the leg equation, you need to use the total number of legs, which is 168. So in the first equation, we need to use how many total insects. What's the total number of insects? In the second equation, we need to know how many legs each insect has and what is the total number. You give it a try, we'll check it in class.